Hey, Mr. Harridan here. We're going to talk about intermolecular bonding versus intermolecular forces. Okay? Are you ready for this? I think you are. Now, here we go. So we're doing intramolecular bonding. Okay? This is the bonding that is within the compound, okay? Meaning inside the molecule. For example, water has hydrogens and oxygens holding together. That would be intermolecular bonding. These are strong interactions. For that one, that would be covalent bonding, okay? So, intramolecular bonding are the bonds that hold the compound together. Okay? We are going to list these from the strongest to the weakest. There are 4. Okay? One I have not even introduced you to. Number 1 is a network solid. You'll learn more about those in AP. Okay. Second one is metallic bonding. So metals and the alloys that we're talking about have metallic bonding, and those are the strongest. Shouldn't this say intra? Yeah, let's just say intra right there. Molecular bonding. Okay. Ionic bonding is next. That's the bonding between metals and nonmetals. And then finally, there is covalent bonding, which is the weakest of those. Okay. Those are within the molecule. Those are the actual bonds. Okay. Then we get to my favorite ones to talk about. This is the ones that you talk about more in classes here, are the intermolecular forces. Okay? These are the forces holding one molecule to another. Due to the polarity within the molecule, there are poles. Okay? And I have no idea what that blank is right now. These are forces holding due to the polarity of molecules. There are poles. We'll say there's attractions. Between the positive and negative ends of molecules. No, it's not. No. This is the word between, Mr. Harridan. Come on. Between, I see it now. Intermolecular forces are between the molecules. Okay? Can't believe I made that mistake, Mr. Harridan. You should know intermolecular forces are between molecules. Okay? Intermolecular forces are weaker than intramolecular bonding, because the intermolecular forces are between the molecules. Okay? So I'm talking about 2 different molecules and the forces between them. Okay? So over here on this picture, the intermolecular force is between the molecules. Okay? Here's a water molecule. Here's a water molecule. This is the intermolecular force that's between the molecules. Okay? They would consider this hydrogen bonding, which I will get to in a second. Okay? Back to the other part of the page. Okay. There are 4 types of intermolecular forces. Okay. There is, and we're going to list these from strongest to weakest. Again. Okay. The first one is ion-ion. That is between ionic compounds. Okay. And we'll go more into this in the next video here. The next one is hydrogen bonding. Hydrogen bonding is for polar molecules. These are for H with N, O, or F. Okay? That is how you know if it is hydrogen bonding. Okay? The other one there, that's polar, is dipole-dipole. And I can't spell dipole-dipole. D-I-P-O-L-E, D-I-P-O-L-E. Those are also polar. Okay? Because the dipoles are the partial positives and the partial negatives I draw. The weakest is London dispersion, which is in the non-polar range. Okay? So if you can't read that, the order is ion-ion, hydrogen bonding, dipole-dipole, and London dispersion. That is the order from weakest or strongest to weakest. And I will go over how to identify those in the next video. Okay, I think there's like one more blank down here that I was getting confused because I was looking at my notes. And da-da-da-da-da. Intermolecular forces hold the substance together as a solid or liquid, because we introduced that to you in chapter 1. Okay? This is the reason why gas particles can go anywhere they want, because the intermolecular forces between them are broken, they are weakened, and they have freedom of motion. Okay. You guys are champions. The legend is out.